Hello everyone, in this video I'm going to discuss the example for differentiation. Given we have the situation y to the power of 3 equals to exponent power x minus y, shows that we have the first derivative equals to y over 3 plus with the y, and also the second derivative. So let's begin. dy dx, we have 3y squared. Since this is not the x, so we have to add on the dy dx. Continue, equals to, differentiate the exponent, we have the situation exponent x minus y. Focus on the power, so we have differentiate the x and we have 1 minus the dy dx. Kindly rearrange the situation. So 3y squared, we have the dy dx equals to exponent x minus y minus the exponent x minus y, then we have the dy dx. Rearrange, then factor the dy dx. So we have the dy dx, bracket, we have 3y squared plus exponent x minus y equals to exponent x minus y. Continue. We have the dy dx equals to, we have the exponent x minus y over, we have 3y squared plus with the exponent x minus y. Then kindly refers to the situation here. We have the exponent x minus y, which is equals to y to the power of 3. So kindly substitute the situation. So we have the dy dx is equals to, where we have the y to the power of 3 over 3y squared plus the y to the power of 3. Kindly factor out the y. So factor out the y squared, then we have 3 plus with the y. So notice that we can simplify. So we have the dy dx is equals to, we have the y over 3 plus with the y. Then we already show the situation. Next, we are going to focus on the 2. So here we're going to differentiate for the second time. Let's say this is a u and this is the v. So by using the quotient rule, we have v u prime minus u v prime over v squared. So for the second derivative, so we have the second derivative is equals to, start with the v, so 3 plus with the y, bracket, differentiate the y and we will have the y prime, minus, we have the u, and then differentiate the situation and we will have 3, we have 0, then again y prime. So over the v squared. So 3 plus y bracket square. Kindly factor out the y prime. So we will have the y prime and then bracket. So 3 plus with the y minus y over 3 plus with the y bracket square. Rewrite the situation. We have the y double prime equals to, we have the y prime bracket 3 over the 3 plus with the y bracket square. Kindly cross multiply the situation. So we have the y double prime multiply with 3 plus with the y bracket square equals to, we have the 3, the y prime. So as we all know, the y prime is y over 3 plus with the y. Continue, cross multiply the situation again. So we have the 3 plus with the y bracket cube. And then we have the second derivative equals to 3y. So rewrite the situation. 3 plus with the y bracket cube. Then we have the second derivative. And then minus 3y equals to 0. So from here we already shown the situation. Kindly refers to b. So here we have given the parametric equation for the following curve. So x is equals to 2 plus we have the cos 2t bracket power of 1 over 2. Next we have the y equals to 1 minus bracket sine 2t power of 1 over 2. So differentiate the x with respect to t. So we have the dx dt equals to 0. Then we have 1 over 2 bracket cos 2t power of negative 1 over 2 bracket. We have negative sine 2t and then 2. Rewrite the situation. Dx dt equals to, we have the negative sine 2t over the square root of cos 2t. Next, focus on the dy dt equals to, differentiate the 1 and we will have 0. Then negative 1 over 2 bracket sine 2t bracket negative 1 over 2. Differentiate the sine and we will have cos 2t. Then we have the 2. So dy dt equals to, we have the negative cos 2t over the square root of sine 2t. Next, we have the dy dx equals to dy dt multiply with the dt dx. So negative cos 2t over the square root of sine 2t. Multiply. Do remember to flip this part. So we have the square root of cos 2t over negative sine 2t. So from the situation, we have the negative cos, negative sine. So where we will have the situation which is the cotangent 2t. Next, we have the square root of cos, square root of sine. So cos over sine, again, we will have another square root of cotangent 2t. So the dy dx is equals to cotangent 2t bracket, we have 3 over 2. Because here we have 1, here we have 1 over 2. So the roots of indices, 1 plus with the 1 over 2, we will have 3 over 2. So that is the dy dx. Next, for the second derivative, we have the formula. Differentiate the dy dx with respect to t. Multiply with the dt dx. So kindly focus on this part. If we differentiate, and we will have the situation 3 over 2 bracket cotangent 2t bracket 3 over 2 minus 1, and we will have 1 over 2. Differentiate the internal function. Differentiate the cotangent, and we will have negative cosecant square 2t. Continue. Differentiate the internal function here, and we will have 2. And then multiply with the dt dx. Square root of cos 2t over the negative sine 2t. Kindly rewrite the situation again. So we have the second derivative where we have the situation negative 3 square root of cotangent 2t. Multiply with cosecant square 2t. Then multiply with square root of cos 2t over negative sine 2t. So from here we have the 3, and then we have the square root of cos 2t over sine 2t. Multiply with the situation 1 over sine square 2t. Multiply with the square root of cos 2t over sine 2t. So from here we can see that the square root of cos 2t multiply with the square root of cos 2t, and we will have 3 cos 2t over. So from here we have the sine squared 2t, and then here we have square root of sine 2t. Then here we have sine 2t. So from here we have square root of sine 2t. Then we have sine cube 2t. So if we simplify the roots of indices, we have 1 over 2 plus with the 3. So we will have 7 over 2. So finally, the second derivative we have in here is 3 cos 2t over sine power 7 over 2 2t. So that is the situation for the second derivative. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.